Hi everyone, it's Coach Fred here, and today we're going to be talking about piecewise functions, which are not just your average function. Okay, so piecewise functions really are just like their name says, they're pieces of functions. And we're looking at them in small little windows of the function. So we might be looking at a line between x's of say 2 and 8, or we might be looking at a parabola, we could be looking at a square root function, but it really is just pieces of functions. It can have gaps in it, it can have holes in it can go on forever, but that's basically what it is. And so we have to recognize what they look like and where you're looking at them. So a piecewise function typically is going to have 2 or more parts to it. This one that I'm looking at here has 2. And so you can think of them as their own separate function. They really are f of x equals, 2x minus 1 plus 3. And you could also think of it as f of x equals negative x plus 1. But you're only looking at them on this piece. This is what we like to refer to as the domain of the function, meaning the x's that you're going to look at. So what this is saying is I'm going to look at this function. I want to draw this function where x's are negative infinity all the way until they get to 2. And because of the bracket, they want us to include 2. So, there's lots of ways for you to think about this. The way I like to think about it is I just like to think about first what type of function that is. So that's actually a linear function. For me, I'm going to then make a quick table for myself. And you might be saying, why, Coach Fred? Why are you making a table? Well, you could put it into y equals mx plus b and graph it. You certainly could, except I want to use the points that are in the domain, and sometimes they don't actually include the y-intercept. So now I'm going to plug in always the endpoint. Even if it's not included, I'm going to use that endpoint. So I'm going to plug in 2. But then it wants me to use everything to the left of 2 along the x-axis. So I might pick 0 and I might pick negative 1. I'm going to plug them into that function because those numbers are within the domain of that function. All right, I'm going to actually make this a little bit easier by simplifying. So 2x minus 2 plus 3 will give me 2x plus 1. Okay, so if I plug in 2, I'm going to get 2 times 2, which is 4, plus 1, which is 5. If I plug in 0, I'm going to get 1. And if I plug in negative 1, I'll get negative 2 plus 1, which is negative 1. I'm going to plot those points. So 2, 5. At 5, I'm going to put a closed circle because it does include that number. 0, 1, and negative 1, 1. Okay, and then I'm going to take my pencil and an arrow, but remember, I'm only drawing a piece of the function, so I'm going to be drawing everything from here this way. It goes on forever. I'm going to put an arrow at the end of it. Like that. Okay, now I'm going to go to look at the other function. So for the other function, I see a line as well. It wants me to start from 2 to infinity, so I'm going to include that endpoint of 2, and then maybe I'll put in 3. It's a line as well. All right, now this is a great example as to why I'm not using the y-intercept in slope-intercept form, because I'm not really looking at it at the y-intercept. I'm looking to the right of 2. So if I plug in 2, I get negative 2 plus 1, which is negative 1. And then if I plug in 3, I get negative 3 plus 1, which is negative 2. All right, so I have 2, negative 1. I'm putting an open circle here because it does not include it. All right, and then 3, negative 2. So right there. And so I'm going to be looking at the graph everywhere this way. And that's a piecewise function. Okay, so again, a piecewise function, f of x equals, it can have an unlimited number of pieces. We're going to be looking at ones that have 2, 3, maybe even 4 pieces. And on the right, it's the domain. Now, this domain is written in interval notation. It also can be written in inequality notation. So it could say x is less than or equal to 2 and x is greater than 2. It's written both ways, so you want to feel comfortable with both. All right, let's look at writing a piecewise function from a graph. Okay, so we can see that we have line graphs, so that makes it really helpful. So for the first one, let me restart that. I got ahead of myself there. for the first one, I'm actually going to get started. I see I have two parts, so I know when I'm writing my function, I'm going to have two parts to it. So f of x equals. I'm going to get my domains in first. So the graph on the left, it looks like I'm going to be starting at 1 and going towards infinity. So I'm going to write that using inequality. So that would be x is less than 1. And on the other side of the graph, so this graph, I'm going to be starting at 1 and I'm going towards infinity, positive infinity. So that would be x is greater than or equal to 1. All right, now I'm going to look at the first one on the left. It's a line, and so I'm seeing a y-intercept here of 1, and I see a slope. Let's see. I'm going to go up 3 and over 1. So up 3 over 1 gives me a slope of negative 3, up 3 to the left 1. So that's negative 3x plus 1. That one was nice and easy because it went through the y-intercept. Here, lots of different ways you could think about this. You could first find your slope. In this case, I can see that the slope is up 1 over 1. So my slope is 1, but my y-intercept isn't on the graph. But if I went down 1 over 1, I'd be at a y-intercept of 5. So I could do that. I could say x plus 5. Another way to do it would be if it weren't so close and you couldn't use the slope or the slope was funny, you could take 2 points on the graph, because remember the minimum you need to write an equation of a line is a point and a slope. Find your slope and then use point slope and then just put it into y equals mx plus b. You might notice, because these are in f of x form or function form, if it's a line, it's going to have to always be in the y equals form. Okay? All right, let's look at the last thing we might have to do. We might have to graph a function that has more than one function. And there's a function on here that sometimes can get tricky. So this one has a line function, a quadratic function, and what's this? It's hard to see it sometimes with a piecewise function, but if I wrote it like this, would that be better? Or even better, would it be this? Again, that's the constant function or a horizontal line, and that can be a little tricky. So I'm going to break this up, and I'm going to make my tables. So here we go. My first function right here, 2x plus 1, I'm going to plug in 0 and maybe negative 1. That should do enough for me because it's a line. So 0 gives me 1. Negative 1 gives me negative 1. So I'm going to go to x of 0, y of 1. I'm going to put an open circle because it doesn't include it. And then I'm going to go to negative 1. Sorry, I did that wrong. 0, 1. I put it in the wrong place. So 0, 1 would be right here. And then negative 1 would be right here. So I have a line going like that. All right. Between 0 and 1, I have a horizontal line at 6, but it's a closed circle. So I'm going to go up to 6 between 0 and 1. And so I'm going to have a closed circle here and an open circle at 1. And so it's this tiny little horizontal piece. Let me make that bigger. And then from 1 to 3, I have a parabola. Now, it's important for you to notice here, I put in the endpoints. I put in 1, and I might put in 2, and I might put in 3. But always put in your endpoints. All right, so if x is 1, y is 1. If x is 2, y is 4. And if x is 3, y is 9. All right, so it's important to know this graph, its vertex is at 0, 0. So you're going to be only looking at a weird part of the graph. Okay, so 1, 1, I'm going to have a closed circle. 2, 4, closed circle. 3, 9 up here. So it looks kind of like this, and we have to know it's a curve going up like that. All right, so today, let's just recap. We learned what a piecewise function is. We've learned about how to write them in terms of their domain, and we learned how to graph them, okay, by using a table of values. Hopefully that's helpful. Have a great day.